graph the following function. They give you a cotangent function and they want you to graph it over 2 periods. So let's look at the components. First, the 1/2. That 1/2 will be your amplitude, that's the value of A, will be 1/2. Your period, now remember that for your period, it's going to be pi divided by B. In this case, there's no coefficient here, so automatically the B is 1. So therefore your period will be pi. We do have a phase shift of pi Now remember, this is a positive, so your phase shift will be negative pi. That means that we're going to shift the whole graph to the left pi units. And the next thing that we need to are your asymptotes for your cotangent. Remember, for your cotangent we have two asymptotes. The first one is x equal to 0. The second one is x equal to pi. I am missing something. I'm missing the value of b, which is just in this case 1. I don't need to solve for x. It's already solved for. It's just 1x equal to 0 and 1x equal to pi. So let's go and build our graph. We're not shifting it up or down, so therefore I can place my y-axis at the center. And we are shifting it to the left a bit. So therefore I'm just going to place my y-axis a little bit at the center, so that way I have enough space to shift it to the left. And my period is pi, and my asymptote is 0 and pi. So therefore I'm just going to make each one 1, 2, 3, 4 is pi. 1, 2, 3, 4 will be 2 pi. To the left, 1, 2, 3, 4 will be negative pi, and 1, 2, 3, 4 will be negative 2 pi. Now, ideally, my asymptotes will be from 0 to pi, but in this case, we are shifting it to the left negative pi. So therefore, I'm going to add my period, add my phase shift to each one, so I'll be minus pi to each of my asymptotes. That way I shift each of my asymptotes. So therefore 0 plus negative pi will be just negative pi. That will be my first asymptote. Pi minus pi will be 0, and that will be my second asymptote. So therefore we are shifting everything to the left. Now remember, when you're dealing with cotangent, you want to be able to add your phase shift to each of your asymptotes. So my first asymptote will be a negative pi. My second asymptote will be at 0. Notice that my period is still pi. So the distance from here, from my first asymptote to the second asymptote, is going to be pi. Now we are going to divide it in 4 sections. Half it, half it, half it. We are dealing with cotangent, or amplitude is half. So we're just going to go up half and down half. And your cotangent will go something like this. So therefore, on your first half, or your first quarter, will be at 1/2, then 0, then negative 1/2. And that'll be my graph. So we're going to come down, make a quick turn, and come back down. It's getting closer and closer to the asymptote, but it's not touching. That is the first period. I wanted to do it in another period. So therefore I need to find my other asymptote. So I'm going to take my end asymptote, which is 0, and I'm going to add my period. So plus pi. So therefore my next asymptote will be at x equal to pi. And visually you guys should be able to tell that your other asymptote should be at pi, because your period is pi, and the distance once again between both asymptotes is pi. Some of you guys will say, oh, it's 1, 2, 3, 4, 1, 2, 3, 4, which is perfect, but I want to make sure that you guys understand the math as well, algebraically. Once again, I'm going to divide it in 4 sections. I'm going to take half, 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 your amplitude is 1/2, so therefore it'll be 1/2, 0, and 1/2. And once again, I'm going to make my other cotangent. I'm going to come down, I'm going to turn. It's going to get closer and closer to the asymptote, but it's not going to touch it. And there we have it. We have a cotangent that has been shifted to the left too. Remember, you want to double check. Your amplitude is 1/2? Yes. Do we shift it to the left? Yes. And make sure that we did both periods? Perfect.